Hi, and welcome to my talk on making database changes easy for application developers. My name is Nathan Voxland. Just a quick background on me. I've been an application developer myself for over 20 years now, working on a large variety of projects and for several different companies. I started Liquibase as an open source project just over 15 years ago to solve a problem I was personally having trying to keep the databases in sync with the code changes I was making. Now, currently at Liquibase, the company, I continue not only to work on the development of Liquibase, but also across the company and with the community as a whole in order to make Liquibase the easiest, safest, and most powerful change management solution around. Today, I'm going to be primarily talking about how Liquibase can make your job as a developer easier and how to most efficiently work with it. But we'll also quickly touch on Liquibase in general, as well as how to fit it into the rest of your company. So what is Liquibase and how does it make database changes easy? Now, Liquibase's job is to make sure that the database structure your code expects is the same as the database that you actually have. Whether you're first setting up your development environment or pulling in code changes from other people, Liquibase makes sure that every table and every column is the way that it should be. And that goes for all of your databases. As your application changes get deployed through integration systems and onto production, Liquibase makes sure that the same changes are applied correctly and consistently all along. So let's start with a quick demo so you can see Liquibase in action and understand what's happening behind the scenes. Just to set up the background a little bit, I already have installed the Yugabyte database. I've already installed the Liquibase CLI. And I have my IntelliJ running both for kind of code and looking at the database a bit. The database is empty and the files are empty. So bringing up my project here, we're going to start with an empty changelog file. Terminology wise, the changelog file is basically your source code file that stores all of the changes that you're looking to make. And then within this changelog file is going to be a set of change sets, where each change set is the unique piece that Liquibase is tracking to know whether that particular step has been ran against your database or not. So what I need to do is first add my first change set. Using a formatted SQL format here. We'll talk about some other changelog formats in a minute. But the goal of this formatted SQL is to look and work like a regular SQL file, even though it has some additional metadata that Liquibase understands in here. And so, and the metadata is in these comments like this. So I make my change set. I need to uniquely identify the change set. In this format, what we do is we identify it with a string like this. Liquibase tracks each change set by both a combination of both the ID and an author. The ID is just a simple string here, like in this case it's 1, but this could be anything, create table A, whatever I want to put here. And then the author is in there primarily as a way to make sure, as sort of as a namespacing mechanism, so that you don't have to coordinate what you use for an ID across everybody else. You just have to know that you're making identifiers that are unique for you. So what I'm going to do is I'm going to just specify the SQL that I want. I'm going to make a person table. That's a primary key, and it has a name. That is a varchar 50. There we go. Now that I have my file, what I can do is I can run Liquibase update. So the update statement is the update command is what applies that changelog to your database. You can see I'm specifying the changelog file as an argument. I'm specifying the URL. Liquibase is a Java-based program, so you need to find the JDBC URL string that makes sense for your database. And then I'm just using the regular insecure Docker configuration, so I don't need a password or anything at this point. Run Liquibase update. And it will apply my changes, so that now, for example, if I were to open up the Yugabyte view you can see I now have a person table that got added to the database. Within here, you can see it has my name column. It's got the ID columns that I have in there. The other two tables that it created was a database changelog table and a database changelog lock table. These are the two tables Liquibase uses for tracking the changes. If I go back over here as an easier way to see, if I select from that database changelog table, just so you can see what's going on, it stores in that single record for each change set that has been identified or has been executed against this database. You can see it stores the ID, it stores the author. It also stores the file name in here as well too, so that as part of that unique identifier for the change set. So that way, if I'm breaking up my change log into multiple files or running multiple like independent change logs against the same database, I don't have to worry about duplicating these ID columns across the file names. I just have to make sure that the IDs are unique for ones that I made within this particular file. And then it also stores the extra metadata about whether it was ran and the time and that sort of thing. Once I've created that table, I can certainly make additional changes to it as well. Like maybe I realize it should have a last name column, so I can just create an additional change set. It has to have a different unique identifier. And then I'll do table person, add column last name, varchar 20. I can run my Liquibase update again. And you'll see that it was updated successfully. Notice it didn't fail trying to rerun that create table with any sort of object already exists, because Liquibase is tracking what has ran and what has not ran so far. The other thing that's a good idea to do is all of these arguments, get long to have to put in all of the time. And so what you can do is you can make a Liquibase properties file right in the same directory, working directory that you're running in, where you can specify the changelog file, the URL, the username, whatever else that you need. And Liquibase is automatically going to run for that, look for that that file for configuration. So I can just run Liquibase update like this, and it's going to see what there is, or it's going to find that and automatically run. One thing to point out as well here too is that when I found that I needed to add that additional column, I didn't go back and change the initial create table statement. We're not trying to define what we want the tables to look like, sort of a state-based system. Instead, what we're doing is we're defining the particular steps that we need to do to get from point A to point B. And so it's a series of evolutionary changes along the way. So now that you know what Liquibase does, how do you fit that into your development workflow? Let me bring up my slide so you can see that. There we go. So it's really usually best to treat it like any other code that you write. You develop along like you normally do until you hit a point where you need to make a database change. Maybe you need to add that line 2 column on your database table, or the last name column on your person table. At that point, you append that new change log to your change log, run Liquibase update, and then make sure that everything works together. Just the classic inner loop, code, test, code, test, code, test, as it goes along. If you mistype something in your SQL, that's just fine. Like you misspell alter or you forget a keyword or something, Liquibase, when you run updates, going to say invalid SQL, give you the problem. You just fix it and run it again. If the change set passed, but maybe something didn't work quite right, like you misspelled the name of the column and it successfully created it, but not the way your code expected it. Then you can there's a Liquibase rollback count command that lets you roll back just the last change set that ran. Then you can make a change, fix the naming, rerun Liquibase update, and make sure that recheck that everything works. That's all really very close to what you'd maybe normally be doing without Liquibase. Perhaps you normally just have your database ID open, you write the SQL that you want just in your IDE's SQL editor, run it until your database is in the right spot. It's the same thing you're doing, just with the difference being that you're initially storing those changes in Liquibase and then running them through Liquibase, because that way you're sort of forcing that you're not going to be accidentally forgetting some of these changes that you needed to make. And then it gets lost along the way until your application gets to production and all of a sudden doesn't work because you forgot that, oh, the column needed to be a little bit bigger than that example that I had sent in, or something like that. So that's really that high level of how do I fit Liquibase, or how do you do Liquibase? But as you all know, the complexity is always in the details. So how do you best apply those general Liquibase concepts to yourself in particular? The first thing I wanted to talk about is the format of your changelog files. As you saw before, what Liquibase is really in the end doing is just tracking whether particular change sets have been ran or not. And we support multiple different ways for you to write and define those particular change sets. We saw the formatted SQL example from before, but we also support what we sometimes call structured change logs. Those can be written in XML or YAML or JSON. I'm just going to show XML as the example here. YAML and JSON have exactly the same structure. They're just really kind of a direct mirror of each other, just indented differently and with less angled brackets. So you can see in this example here, it's still just a regular SQL statement like I had before. Really the only difference is that now this change set is defined this way in an XML tag with ID1 and author broken up this way, and I have my SQL in here as well. But this XML and JSON and YAML have some additional features they can support on top of the raw SQL as well. In particular, what it lets you do is rather than specifying the exact SQL you want, it can describe the SQL that you want done. In this case, we're wanting to create a table named address, with this ID and line column. And you're not specifying the exact SQL you want, you're just describing what you want and leaving it up to Liquibase to figure out how to convert that into the correct SQL for you. Think of it a lot like trying to call a function from a library versus coding something for yourself. You lose that ability to specify the implementation exactly, but it also lets you kind of rely on that pre-existing logic. One of the big advantage this function style gives you is database independence. The same change log can be ran against multiple different database types. For example, maybe you use Yugabyte as your real database, but your SQL or your unit tests you want to run against SQLite. There gets to be differences in the raw SQL, but this function style would let the same change log be able to run against both databases just fine. The other advantage to this function style is that you don't have to know SQL. For some teams, avoiding SQL is an advantage. For others, it's a disadvantage. Which you pick is up to you. And we work with both. And finally, this function style helps explain to Liquibase what is going on, so that Liquibase understands that what we're doing in this change set is creating a table. SQL is opaque to us. We don't try to understand what's going on. But when we see a change set like this, where we know that we're calling the create table function with an address, we know that in order to roll that back, you have to do a drop table address. And so Liquibase is able to generate that for you, so that you don't need to manually specify that in order to do rollback statements and that sort of thing. With formatted SQL or with even in XML for change sets that we can't, from that change set figure out what the SQL to roll it back would be that rollback statement needs to be manually set up by you. So think about what works best for you between those formats. Like I said, different people, different teams have different strengths and weaknesses and things they like and don't like. Find what works for you. Don't force yourself into using something that you don't like. One thing you'll notice is that all of those are designed to be version control friendly. They're all text-based. That ID author path is there in large part also to support merges in merges in your code. We track each of those change sets individually in that database changelog table. So if you merge in code changes from somebody else and the data and the changelog change sets come along and get merged into that changelog file as well, even though they're up higher in the changelog than yours, then maybe where you're working towards the bottom, Liquibase knows, oh, these new change sets haven't ran against this database, so it runs them. The other thing that helps avoid version control issues is that the change sets tend to just be, you add them to the bottom of the change log all the time, just appending to that file. And that tends to work well, avoiding text conflicts as well. Or if you do have any, they're easy to manage. Also, we do support the ability to break up these changelog files into multiple different files based on include logic. Usually it's best to just start out with a single file until it starts getting unwieldy, and then shift from there. So getting back to your inner loop a bit, how should you actually run that Liquibase update? Now the CLI is always available, but that can sometimes feel a little bit out of band for your workflow. It's a separate tool with different syntax to remember and to call. So as an alternative to just sort of raw CLI usage, you can integrate it more directly into your specific build tools. Like we ship with Maven, Grails, Ant, and NPM build systems. I'm trying to think if there's any more. That's probably most of them. But if you're using other things, MS Build, whatever, there's many of them actually have community examples and community libraries out there already. If they're not, usually every build system has some way to call out to the CLI and wrap your particular usage of Liquibase into that build tool. And that can go a long way towards making it easy for yourself and other developers to really speed along that inner loop of make a code change, make my database change, do my update, without jumping back and forth between tools. Another common pattern as well too is really even just to build Liquibase into your application startup. Because we're a Java library, we have an API that lets you embed Liquibase directly into your startup. If you're directly into your program. If you're using other technology stacks, you can use things like our Docker container or make calls out to the pre-installed CLI. But what's nice about basically, just doing a Liquibase update automatically on startup every time is that it avoids any chance of forgetting to do the update, and it makes it really can kind of consistently apply that update, just both on your machine and then as the change log. If you bundle the change log in your packaged up application, and then as you ship that application to integration testing and to staging and and then eventually to production or to your customers, that update process that makes that allows Liquibase to make sure that the database matches what that new artifact has are really kind of well tied together and just kind of automatically get taken care of for you. So while that doesn't always work for everybody, it is a common and useful way to run Liquibase as well too. One thing to give you a real quick heads up on as well too, we have an exciting new feature coming up called quality checks that'll be rolling out in the next couple weeks. Quality checks really kind of work a lot like an automatic linter. It ensures that the change sets that you and everyone on your team makes are going to match your personalized quality standards. For example, you want to make sure your naming conventions are followed. You want to make sure that you don't forget to create a primary key, that your transaction attribute on your create table gets specified. Whatever you want to make sure you set yourself does, whatever you want to make sure everyone else on the rest of your team does, you can encapsulate it into rules that Liquibase will ensure are being followed. So keep an eye out for that. Now, this is normally more of an advanced topic, but as application developers, I have faith in you. So one of the great things about Liquibase is that it's extremely extensible. Almost every part of Liquibase can be extended or replaced to make your life easier or fit better into your workflow. Like maybe there's a common but complex change that you often do. You can roll that up into your own custom change function that you can add into your XML or YAML files, just like the create table example above that does whatever particularly complex thing that you normally do. Or maybe if you want to log these database changes off to some proprietary system that you want. Maybe you want to add more quality check rules. Whatever you want to do, Liquibase will have a plugin point for you. So while it's maybe not something that you need to look at day one using Liquibase, definitely keep it in the back of your mind on what can make your life easier and the rest of your team's life easier as well too. Then finally, a couple gotchas to look out for. So first, remember that if you modify that while you can modify these change sets while you're initially writing them as a developer, once you commit or push those changes out to others, it's really sort of out of your control. From that point on, the changes need to kind of roll forward. What you're really kind of trying to do here is have a evolutionary database practice here, where you're chaining a set of changes on top of each other, and once you commit and push your change, it's set out there, and you're just kind of rolling forward from there. Liquibase does track the checksums on the change sets as they get applied to various databases to catch times when perhaps a change log was initially created with a size 50 column, and then somebody goes in and edits it and changes it to 100 or something like that, and then tries to redeploy the change log to that system. It's going to complain saying that the checksum is different because now the change log is expecting the database to have a different column size than it really does. And so we want to kind of make sure that that kind of change was happening in there. Second, each of those change sets, Liquibase is going to try to run in a single transaction, because that way it can make the change and then mark the change as ran in the database changelog table and then commit it. But if you're doing multiple statements in there, which can, sometimes there's going to be statements that auto commit. And so if you create one table, create another table in the same change set, if this first table succeeds and then the second fails, that roll back the transaction that Liquibase tries to do won't actually roll back that first create table, and subsequent attempts to run Liquibase will fail with a table already exists error. So the easy rule of thumb is that each statement should have you should only have one statement in a change set. There's definitely exceptions to that based on how transaction handling is done, but make sure that your change sets really can be run as a single process or as a single transaction. And like I mentioned before, look for evolutionary database industry best practices and follow those. There's lots of options on and lots of best practices on how to be best kind of shifting your database along, what you can do to help prevent downtime and all of that. So keep an eye out on that as you're defining these particular changes that you want to do. So hopefully that helped you see how you can fit Liquibase into your workflow, how it can help you out, and how it can make your life more efficient and easy. But before we go, I wanted to make sure that you're also thinking about everyone else on your team as well. Because remember, you're just the start of the pipeline. And many of these tips and techniques that you come up with for how to use Liquibase for yourself as an application developer can apply well downstream as well too. But also don't force them if they don't fit as well. While the change log should be consistently ran all the way along, how Liquibase gets run can certainly vary. So you can look at things like, how do you best fit Liquibase into your build servers? Or maybe you prefer to have the build server simply package up your changelog file into a zip file, or in your application somehow, so that your deployment software will run Liquibase as it deploys things places. As you head towards production, maybe there's some cloud native integrations like the AWS or Azure toolkit that you want to embed Liquibase into and take advantage of. Remember, Liquibase is flexible and powerful. Find what works for you and for your whole team. And remember that programming is not purely a code thing. It also takes people. And Liquibase has a lot of ways that help support that needed collaboration. We have things like dry run features that can be built into your process. You can have your build servers and systems run things like your update SQL command or the future rollback SQL command, which will not actually update the database, but will specify what will run, so that you can give that script. You can have that script as an artifact of your build or deploy process that your DBAs are able to look at and verify that everything is looking good before actual deployment. Future rollback SQL is there to say, this is what SQL would need to be ran in order to roll a new deployment back to the current state, which can be very useful for disaster recovery planning and that sort of thing. And so incorporating that into those sort of build and processes can be very helpful as well too. And make sure to check out hub.liquibase.com. Liquibase Hub is really a lot like GitHub versus Git. It provides that always available web-based management and collaboration tool that helps get everyone a view into what's happening across all of your databases. Kind of helps you see that sort of larger picture versus the Liquibase CLI that's always just kind of more the single point in time, sort of more developer focused tool. So thanks for stopping by. Thank you for your time. I'll leave you with some links here to learn more about Liquibase and how it can help you out. And thanks again.